Welcome to the video for Pre-Calc 2.6 Day 2. We're going to finish up graphing some rational functions here. So let's get started with a little review. I just, put a function on here. For the horizontal asymptote, it's the power struggle between the numerator and the denominator. Denominator is more powerful, it's the x-axis. Numerator is more powerful, no horizontal asymptote. If it's a tie, you make a ratio of those leading coefficients. To find x-intercepts, set the numerator equal to 0. Denominator equal to 0 will be the possible vertical asymptotes. Don't forget to factor and cancel first. And if you let 0 in for all the x's, you'll find your y-intercept. Just a quick way to find a few of these key points of our graphs. So, first, sketch the graph of x over x squared minus x minus 2, x over. I'm going to factor that x squared minus x minus 2. That's got to be an x minus 2 and an x plus 1. X plus 1. And let me see here. I just make a new slide and we can start working on the graph as we go. Here's x and y axes. And let's see. The intercepts. First thing, x-intercepts, if we set the numerator equal to 0, you get x is 0. So that's an x-intercept. Vertical asymptotes. We cannot cancel with anything in the numerator. So the vertical asymptotes, we're going to set this equal to 0 and get 2. X equals 2. And we'll set this one equal to 0 and get negative 1. Negative 1 and positive 2. Negative 1. I'll put positive 2 right about there. There's our vertical asymptotes. Horizontal asymptotes. Let's see, go back to the original. It's x over x squared. The denominator is more powerful. That means the x-axis is a horizontal asymptote. Okay. Now we've got our one x-intercept, that's also a y-intercept. We got to be careful here. We don't know, the graph might go like this, down and across this way, or it might go like this, or it might even be parabolic, like something like that, or like this. So we got to be careful here in between these asymptotes for sure. We're going to do a couple of additional points. It looks like a real easy one to figure out would be x is 1. Let's put a 1 into our original function and see what comes out. So if we put a 1 in here, we're going to get 1 in the numerator. 1 squared minus 1 is 0. Minus 2 is negative 2. So when we put in x is 1, out comes a negative 1/2. 1 comma negative 1/2. So if we go over to 1, we're down here at negative 1/2. Okay, now we got an idea. At least this part of the graph is going to go like this. Now we're not sure again over here. We might come back down or we might bump up. So let's see. It looks like it'd be a safe idea to put in negative 1/2 and see what comes out of there. So if I put in negative 1/2, I'm going to get negative 1/2 in the numerator. And then if we square that, that will be negative 1/2 squared is a 1/4 plus a negative 1/2 and then minus 2. So let's see, our numerator is a 1/2. Denominator is 3/4 minus 2 would be negative, positive 3/4, negative 1 1/4 or negative 5/4. When we take that up and flip it, we are going to get a number, but more importantly, it's going to be negative. So if we put in that number, no, hold on. Let me back that up. If we plug in positive 1/2, was it positive 1/2? Oh no, negative 1/2. Negative 1/2. So this will be negative up here. This will be negative. When we invert and multiply, a negative divided by a negative, that's going to be a positive. So when we're over here at negative 1/2, we're somewhere up in positive territory, and that means our graph is going to come through and be guided up by the vertical asymptote. Okay, the last thing, it says some other points on the graph. We got to figure out what's going on here beyond -1 and out to the right beyond 2 to see where the graph is going to be above or below the x-axis, because remember, we can't cross it. So let's put in -5 and see what happens. If we put in -5, our numerator will be a -5, and then -5 squared is 25. 25 minus a negative. Our denominator is definitely going to be positive, and a negative divided by a positive is a negative. So that means we're under the x-axis. We're somewhere down here at -5. So as we head to the right, we will be forced down by the VA, and to the right, we will be held under the horizontal asymptote. Now let's go out beyond 2. How about +3? Let's put 3 in there. Our numerator will be a 3. Our denominator is 3 squared minus 3 minus 2. That's a +3 in the numerator, and downstairs will be a 6 minus 2 is 4. And the big thing there is it's a positive 3/4. So that means we're just above the x-axis, and our graph will be up here in between those asymptotes. Okay, good graph, good sketch. I'm sure the books will be better. But there it is, snaking between the asymptotes going through the origin. And then here we were mostly in quadrant 4. This one was up here in quadrant 1. Ooh, this one looks a little scarier. Now let's see. Let's factor this too as we go. X squared minus 9 in the numerator. That's going to be an x plus 3 and an x minus 3. Denominator, that looks like it'll factor to a -3 and a +1. Now, we are going to cancel this for the vertical asymptotes, but remember, we can still get our x-intercepts first. So let me do another new slide for our graph. And it looks like if we set our numerator equal to 0, well, let's follow along with what we got down here. The first thing is the y-intercept. If I put in zeros for my x's, my numerator will be a -9. My denominator will be a -3, so that's -9 over -3, which is just +3. Y-intercept at 1, 2, 3. Next up, the x-intercepts. That's where you set your numerator equal to 0. And since it's already factored, we'll set this one equal to 0 and get -3. And we'll set this one equal to 0 and get +3. So x-intercepts at plus and -3. 1, 2, 3. 1, 2, 3. Vertical asymptotes. Now here, we would have to cancel these out. So now that the x minus 3 factor is gone, we know it's not a vertical asymptote. Let me do this, make that a little cleaner. So here's our reduced function. If we set this equal to 0, we get a vertical asymptote at x equals -1. So here's -1, vertical asymptote. Horizontal asymptote. Go back to the original, it's x squared over x squared, 1x squared over 1x squared. We have a vertical asymptote at y equals 1. Y equals 1. So right here. Now it does say additional points. Oh, there we go. And now looking at this, I think we have a little mistake. I don't think this x-intercept should be here. Because let's go back to our graph. Here after we canceled, we did cancel for the vertical asymptote, but that is going to remove our x-intercept. So the only x-intercept we have here, set this one equal to 0, it's the -3. My apologies. This x-intercept that I did have at 3, we can throw that in the garbage. There we go. Now, where it does say additional points, for a graph this simple, it doesn't look like we need any more. Let the asymptotes guide you. Here I am at this dot at -3. If I start heading to the left, I will be held under the horizontal asymptote. If I start heading to the right, I've got no more x-intercepts. I'm going to be guided down by the vertical asymptote toward -infinity. And here we are at the y-intercept at 3. If I start going to the left, very quickly I see a vertical asymptote. I'm not going to go down because I can't cross the horizontal or the x-axis again, and I can't cross the vertical, so that's going to force me up to infinity. And as we start heading to the right, we will approach but never touch the horizontal asymptote. Okay. And of course, we'll look at the book's graph. Very similar to ours, they found some additional points. And notice above 3, where we had our x-intercept at 3, that's actually a hole in the graph. You know, it's not a vertical asymptote, but it would zero out the denominator of our original function. So try these two, and I believe that will be the end of the video. No, we still got to do a slant asymptote. So come up with a sketch of these and compare it to my answer after you're done. So let's see. If we set the numerator equal to 0, we get 0. That's an x-intercept. If we put 0 in for all the x's, we'll get 0 divided by -2. That's also our y-intercept. If we factor our denominator into x plus 2x minus 1, we set that to 0, we get a vertical asymptote at -2. With this one, we set that equal to 0. We get a vertical asymptote at +1. If we look at our power, 3x upstairs, x squared downstairs, our denominator is more powerful. We have the x-axis as a horizontal asymptote. And we just need a few more points in there. Let's see if we put in a -5. If we get a positive answer, we'll be up here. Negative answer will be below. So if I put -5 in the numerator, I'll get a -15. If I put -5 here, I'll get a 25. -5 is 20. -2 more is 18. And again, it doesn't matter what the numbers are. It's negative. So we're going to be definitely under the x-axis. We're going to be down here. And then my graph will be guided by the vertical asymptotes. Let's see what happens if we put a -1 in there. -1. So my numerator is going to be a -3. -1 squared is 1, plus a -1 is -1 is 0, over a -2. And the negatives cancel, so that's +1.5. I'm going to be up here. So I know the graph is sort of going to look like this. Let's see what happens if we put +1/2 in there. 3 times a +1/2 is +3/2. 1/2 squared is a fourth. A fourth plus 1 is 1 1/4. -2 is a negative. So we're going to have a positive numerator divided by a negative denominator. That means we're going to be somewhere down here, and our graph will look like that. Let's go out beyond 1. Let's even go out to say, let's just do 2, +2. If I put 2 in the numerator, I get a 6. Downstairs, I get 4, plus 2 more is 6. 6 minus 2 is 4. +1.5. That ties my graph up here, and if we head to the left, we'll go up to infinity. To the right, we will approach the horizontal asymptote. Ooh, now this one is a lot like our last example. Let's factor first. Numerator will be x plus 2x minus 2. Denominator looks like an x plus 2x minus 3. And the plus 2's are going to cancel. So, just working with this, it's going to be a pretty simple graph. Let me do a quick xy axis. Set the numerator equal to 0, you get 2. That's an x-intercept. Set the denominator equal to 0, you get 3. That is a vertical asymptote. Our power struggle is equal, so it's 1x over 1x. We have a horizontal asymptote at y equals 1. Now I put my graph too far over here, but I might be able to do this. Whoa. Do this. Good enough. I did lose that piece. Alrighty. There we go. So this x-intercept ties our graph down. If we start heading to the left, we'll be up under the horizontal asymptote. To the right, we'll be guided down by the vertical. And if I extend this out here, 3, 4, let's put a 5 in there. And what was our simplified function on that? X minus 2 over x minus 3. X minus 2 over x minus 3. If I put a 5 in there for the x's, 5 minus 2 is 3. 5 minus 3 is 2. So 3 halves. Remember, this horizontal asymptote is at 1, and that number is bigger than 1, so that puts us up here. So if I start heading to the left, we'll be guided up. To the right, we will approach the horizontal asymptote. Okay, one more example, one more huddle problem, and that has to deal with slanted asymptotes. They're not always vertical or horizontal. Sometimes they are slanted. And I'm not going to read through all of this step by step. The big idea here is, here's a rational function. It looks like division. So we can divide when the numerator is 1 power higher. Here our numerator is x squared, denominator is x. So we would say there is no horizontal asymptote, but since it's 1 power higher, we can divide and get this straight line. When we divide, we're going to have an x to the first. We're going to ignore this remainder because we're heading very far out on the x-axis, but this line, y equals x minus 2, will be our slanted asymptote. Like we'll see here in the picture, y equals x minus 2, there's negative 2 and our slope of 1, and then our graph is contained between the vertical and the slanted asymptote. So, and let me just make a new slide here to start working on this graph as we go through. So here's my xy axis. First, y-intercept. Let's plug zeros in for all the x's. So that'll be a negative 2 over a negative 1 or positive 2. 1, 2 is a y-intercept. X-intercepts. Let's factor the numerator. That's going to be what? An x minus 2 and an x plus 1. Our denominator is x minus 1. Nothing is going to cancel. So x-intercepts, if we set the numerator pieces equal to 0, we'll get x equals 2 and x equals negative 1. So 1, 2 and negative 1 are x-intercepts. Oops, wrong way. Vertical asymptotes, set your denominator not equal to 0, and you'll get x cannot equal 1. That's our VA. All right. Now, if we did for horizontal, if we look at our numerator is more powerful, so we know we don't have a horizontal asymptote, there's none, but it is only 1 power higher, so we can divide and get a slant asymptote. So all that long division we did a while ago is going to pay off here. X minus 1 divided into x squared minus x minus 2. Remember, remainders don't mean anything in this type of problem. So I want to get rid of this x squared. I'm going to have to multiply by x. X times this x will give me x squared. X times minus 1 is minus x. And if we distribute a negative and then add, we're going to get 0, x squared, plus 0x, and we bring down the minus 2. That is our remainder, minus 2 over x minus 1. But remember, the remainder is irrelevant. Here is our slanted asymptote, y equals x, y equals x. Or you could think about it as y equals x plus 0. So our slant, y equals 1x plus 0. So here's our origin. We're going to go up 1 and over 1. So our slanted asymptote is going to go like this. Okay. I don't think we need any additional points. Here I am at the y-intercept, and I know I'm going to start heading to the right. I can't go down across the slant. There's no x-intercepts, so that means I'm going to be forced up by the vertical. And then as I start heading down, I'm going to go through my x-intercept, and then I'm going to be guided along by the slant asymptote. Over here, I have my x-intercept of 2. If I'm at 2 and I start heading to the right, I'm going to be guided away by my slant. And if I start heading to the left, I'm going to be guided down by the vertical. Not the best graph. I'm sure the books will be a little bit better. But we've got the important stuff on there. There it is. They did a few other points in there. It looks like they went a little crazy with the points. Better to have too many than not enough, but we had enough to get by. So the last thing in the video, sketch the graph of this, and then compare it to mine and see what you got. So we set our denominator equal to 0. We get x is 0. That means we have a vertical asymptote here on the y-axis. If we set the numerator equal to 0, 3x squared plus 1 equal to 0, you're going to subtract 1 and divide by 3, and that's a negative number, and we can't take the square root. So this graph has no x-intercepts. Let's find our slant, though. Well, if we look at our horizontal, there would be no horizontal. The numerator is more powerful. But let's long divide. X into 3x squared plus 0x plus 1. So I'm going to need a 3x to multiply and get my 3x squared, and then that would be 0. Bring down the next thing, 0x. We've got an x, so that would be 0 times x is 0x. And we would have a remainder, but the thing is, this is our slanted asymptote, y equals 3x. So y equals 3x is our slant. So I'm here at the origin, up 3 over 1, up 3 over 1. It's going to be a pretty darn steep slanted asymptote. Now here's the thing too, we know there were no x-intercepts, so we're not going to cross the x-axis anywhere. So does that mean my function is going to be over here? Probably not, because we would have a possible x-intercept. It looks like we're going to be stuck in between our functions here. So let's do, I guess we could put in a couple of points. Well, let's do -1. If we do -1, maybe we'll be down in here. So if I plug in a -1, I'm going to get -1 squared is 1 times 3 is 3 plus 1 is 4 over x is -1. So that puts me pretty down steep at -4. Aha! We're in sort of this part of the V, so that means my graph is going to look kind of like this. Let's put in a +2. If I put 2 into my slant asymptote, that would make this point a 6, because my slant asymptote was 3 times x. Let's put 2 into this function and see what comes out. 2 squared is 4, plus times 3 is 12, plus 1 is 13. 13 over x is 2, so that's 6.5. So I know I'm going to be above 6. I'm going to be somewhere up here. And that means my graph is going to kind of be like a parabola in that V-sharp shaped part of that graph. No x-intercepts, no y-intercepts. And it looks like the graph worked. All right, look for the assignment on Teams.